Hello, my name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 163. Page 163, and today is our lesson number 83. Turn to page number 163 and read the problem to yourself, okay? It says, after driving to riverfront parking lot, Bob... Anyway, here's the gist of it. We have a person, we are told that he has already run, he has already run 3¼ miles. I'm going to digress for a second here. Past perfect. Past perfect of run is run. This is a very common mistake the kids make these days, and since I teach prep courses in SAT, GRE and GMAT, this thing appears on the SAT all the time, and that in the new SAT, I'm digressing big time here. Back in the old days, many moons ago, when you took your SAT, there was no writing portion. These days, SAT contains an 800-point writing portion, the purpose of which is simply to check your grammar, because these days people butcher the English language so much that for the last few days SAT has been testing the kids' knowledge of the grammar. And this is one of their favorite. The past perfect of run is not ran, is run. So he has already run, we are told, 3¼ miles. The guy wants to run, he wants to run for 50 more minutes at 8, this is the tricky part, not at 8 miles per hour, but rather at 8 minutes per mile. That's, you have to pay attention to the words. His speed, it takes him 8 minutes to run 1 mile. That's his speed, 8 minutes per mile. He wants to run for another 50 minutes after having run for 3¼ mile. The question simply is, how much farther can he go from that point on and still be able to come back to where he started within that 50 minutes? That's all it is. So here's the picture. Let's draw a little picture so that it makes it easier. We can visualize it. So he has gone 3¼ miles. He wants to run some more distance. Let's call it X miles. And then he wants to be able to come back from there to his starting point. This is his starting point. He wants to be able to come back to it, in which case from here to the starting point he will have to go 3¼ plus X miles. Question is, what is that X? How much farther can he go and still be able to come back at the starting point? Enough talk, let's solve it, okay? I need the room. I don't want to start from the bottom here, so I'm going to erase everything, or perhaps we'll see. So here's what we are told. We are told that in 8 minutes, it's very common, kids these days, they pay no attention to their, I'm going on that subject again. They go around saying, I should have went, I should have did it, I should have saw it, I should have ran. What the hell? Nobody teaches them grammar these days. They butcher the language. They butcher the language mercilessly. In 8 minutes, he can run. We are told that in 8 minutes he can run 1 mile. We are told that. So here's our solution. I'm starting here. In 8 minutes he can run 1 mile. That implies that in 1 minute, that implies that in 1 minute he can run 1/8 mile. Simple enough. If it takes you 8 minutes to run a mile, in 1 minute you must run 1/8 mile. Very simple. Therefore, in 50 minutes, he can run 50 times the amount. That's all. That's it, we're done. It's very simple. So the equation that we get is that this number of miles that we arrived at, which is 50 over 8 miles, in 50 minutes he will go 50 over 8 miles. That quantity has to equal this quantity, this x miles that he has to go, plus this guy right here. So it's 3x, or 3 quarter plus x, plus another x, which is 3 quarter plus 2x. This quantity has to equal this quantity, because they are both the same quantity. They both manifest the number of miles here that he can go in the time that he has allotted himself, which is 50 minutes, going at a rate of 8 minutes per mile. That's it. We have to set up the equation and solve for x. That's all there is. Let's do it on the top. That's the most important part. In algebra, setting up the problem is the most important part. And if you're one of those people, I'm breaking into the sermon again, as you can tell. If you're one of those people who is very weak in word problem, if you have trouble setting up the equation from a given word problem, which is the most important part, as I said, this is the crucial ingredient in it, setting up the equation, that is, because no matter how good you are at solving the equation, if the equation itself is no good, obviously you're going to get the wrong answer. So for that very purpose, to help you improve your ability to solve the word problem, if you're interested, if you want to invest the time, you can go to my channel and look for Algebra word problems. Just go to my channel and look for Algebra word problems, or you can just search for it. Just type in my name, Keshwani, and then Algebra word problem. You will find those. There are 100 videos that I have made. There are 100 problems done. Now they start out at a very basic level, very fundamental level. Make sure you don't skip anything. Make sure you do every single word problem with me, starting from the very basic, even though it may seem very simple. But that's how you build your skill. There has to be a foundation. There has to be a foundation. There is no point trying to build a grand edifice on the top with the foundation being shaky. I'm bringing it to a long time sermon now, because it's not going to work. You're not going to be able to, something is going to go wrong and the whole thing is going to come crumbling down, because it's going to be wrong the way you set it up. You have to start from the very basic, you understand? Anyway, enough of the talk. So 50 over 8 equals 3 quarter plus 2x. That's it. I'm going to write 3 quarter as, instead of mixed fraction, I'm going to write it as a regular fraction. So that's 12 plus 1, that's 13 over a quarter plus 2x. And here we have 50 over 8. So now since on this side we have 50 over 8, and here we have 4, and here we just have 1, I want to make the denominator the same. So let's multiply the top and bottom by 2. Let's multiply the top and bottom by 2. And this guy is 2x. I'm going to multiply that by top and bottom by 8. So if we're multiplying top and bottom by 8, we're basically multiplying it by 1. It doesn't change anything. So now we have the denominator of 8. 4 times 2 is 8. Here we have denominator of 8. And here we have denominator of 8, which means numerator is going to be equal, which means 50 equals 13 times 2, which is 26, plus 2x times 8, which is 16x. That's it. Subtract the 26 and you end up with 16x equals 24, and therefore x equals 24 over 16, which is same as divide the top and bottom by 8, and you end up with 3/2, which is same as 1.5. That's it. That's our answer, 1.5. I'll see you tomorrow, okay? Bye now.